And this lesson is dedicated to someone special. It is?
Kit Kat Company.
I can't hear that.
The Kit Kat Company.
The Kit Kat Company.
People who produce the Kit Kat candies.
Yeah. Okay. I don't know. Kit Kat. Yeah. All right, regrouping. Perfect. Today is the first part of 3.1.1. This is part 1. Okay. It's just identifying terms, and I said etc. because there's other aspects. There's coefficients. There's types of polynomials. So today is really more so of a kind of vocab day. I've been using these terms pretty regularly, but we're going to have the second part of the class is going to be our cootie catcher competition. So we're going to use our cootie catchers. I'll show you at home. Cootie catchers to see if we have these terms down really, really well. Okay. So the competition is going to be how many teams of 2 can find all or get all 8 rounds correct. And so far we have 9 from first, 12 from second. So we'll see how we do against that. Okay. But we've already copied all these down, so I'd like for someone to help me out. What is a constant within these 4 expressions or comparisons? Who can tell me what the constant, maybe there's more than one, what they are, and how do you know? What do you think? Anybody? A constant. Yeah, William. Sorry.
It's unaffected by the variable.
Good, good. So a constant is going to remain the same, unlike a variable. So what would be an example of a constant?
11.
11 is a constant. Good. So 11 is always 11, right? 11 will always be 11. If it was 11x, that would be a single term expression, and it would be variable because the x part can be any number. So 11 is a constant. Who then can see what another constant is in all of these expressions and comparisons? Jason says 4. Okay. That's our other constant. So just here under constants, I'm going to put a couple examples. 11, -2. You know, 1/2 is a constant. A fraction is still 1/2 is 1/2. It doesn't change based on, there's no variable or anything. So this is just, these are numbers. They remain constant. Okay. So unlike variables, they remain constant. Great, great. Let's move on. How about coefficients? Where do we see coefficient? There's quite a few up here. And how do you know it's a coefficient? Yeah, William, what do you think?
They're directly to the left of the variable, and they're directly affected by the variable.
Perfect, perfect. Give me one example up here. I'm going to call a bunch.
8 and 8x.
Good. So actually, I'm going to just circle the x. This is our coefficient. The coefficient is in front of the variable. It tells me that there's 8 x's. There's 8 x's, right? This right here, there's 5 of the x to the 4th power type of term. The type of term is based on that exponent, so it tells me how many of those I have. So let's just put some coefficients. You need to put an arrow to the number out in front because it isn't the entire term. The entire term is another one of these that we'll get to soon. The coefficient is just the number out in front. And we've been using that language, so I hope this is somewhat of a review. So it's the -3, it's the 1/2, it's the 4, it's the number. I'm going to use that language you use. Well, I'll say in front or left of the variable. Coefficient. All right. Very good. Are there any other coefficients up here? Who can name off one other one? What do you think, OC?
I think Malik is too tough.
This?
Yeah.
Yeah. The type of term is x to the 4th power, but the coefficient is out in front. It's a 6. Okay? All right. Monomial. What does the prefix mono or mon mean? One. Single, one. Okay. So, what are we going to look for as far as a monomial? Somebody name off a monomial. How do you know? What do you think? Oh.
8x.
Good. 8x. This is our monomial because
There's only one coefficient.
not the coefficient. The coefficient is part of the entire term.
One variable.
There is one variable as well. But, you know, in the case over here, let's see, you know, if I single out negative 3x, this is also has a coefficient and it's one variable. So to just refine that a little bit, if I can, a monomial only has one term. Okay, one term. So let's go ahead and put some examples. We had 8x. You can have just a number, a 3. So a constant is a one-term expression as well. You can have 5x to the 10th. It's basically just a one-term expression, which is, the expression is just a series of terms that doesn't have an equal sign in there. So here we have the monomial. These we can also say, even though they're for comparison here, you can say that's a monomial. You could say that, oh yeah, that's a monomial. Right. Okay. Who can name off the like terms? This one's pretty straight up. William, what do you think?
5x to the 4th and 6x to the 4th.
We'll take these right here. Call these like terms. What makes them like? Who else can help with that? What makes these terms like terms? Remember, like terms we can combine, we can add or subtract them because they're the same type of term. What makes these the same type of terms? All right, William's the ringer today.
They're the same variable raised to the same power.
Good. Same variable. So I like that you said that. It's not just x to the 4th, x to the 4th. It has to both be the x's as well. X to the 4th, y to the 4th aren't like terms. It has to be the same kind of variable as well. So let's put, how about z to the 3rd is like term with 3z to the 3rd, right? X to the 2nd and 3x to the 2nd. So it has the same variable and exponent. What can be different between like terms? The thing that's different between the two like terms is what? Lawrence, what do you think? What's different between the like terms? Excuse me. These are like terms, but what's going to be different? What can be different between them? What do you think? So it was just clarified that z to the 3rd and 3z to the 3rd are like terms because it has the same variable and exponent. But what doesn't matter as far as there's something that can be different between like terms? The coefficient. The coefficient. Okay. The coefficient can be any number. It doesn't matter. But we're talking about same variable, same exponent. Okay, rounding back, binomial. Let's get this out. What do we think? Someone from the back group, be bold. Or I'll call on you, Adrian. Give me that binomial. What is bi? How about to start? Bi is the prefix for 2. Good. Pass it on to a neighbor. Yeah, that's right. Get him back. All right, what is the binomial? Malik?
2-term expression.
Good. What's an example up here?
X to the 4th.
You got it. All right, let's change color. Binomial. So it just has two terms. X plus 1, c to the 10th minus 3. Could be any variable, any coefficient. Doesn't matter. It just has to be two terms. 2x squared minus 4. Or let's make that different, minus x. So this is just a two-term expression. Again, expression is when there's not an equal sign. It's not an equation. Expression is just, these are all expressions. There's no equal sign. So you have nothing to solve. We can just factor it. All right. How about trinomial? Somebody name it up. Trinomial? What is tri? What does tri mean?
Three terms of music.
Probably, huh? So which one is it?
5x squared minus 3x plus 11.
Thank you. That's probably three terms or something. Trinomial. Good. All right. We'll go x to the 4th plus x minus 3. That's a trinomial. It's just a three-term expression. Okay. Who knows what the prefix poly means?
Multi.
Multi. Okay, so like polytheism. If you study Greek mythology, multiple gods, polytheism. There's a lot of poly words out there. And which one of these is a polynomial? Actually, yeah. There's more than one good option. Yeah, what do you think?
All of them except for 8x.
Right. And these are actually comparisons, but there are two here.
Oh,
So it's
okay.
easy to not see that one. But these two are poly. So we'll go box this one. And let's go ahead and box that one. All right. So it just means multiple terms, multiple terms. So when we go to do the cookie catcher competition, there's going to be some answers that would fit into multiple categories. So as long as you catch that as a team, you can count it correct. All right, the last one, quadratic expression. It's what we've been studying a lot, quite a bit for this whole first semester. And what was in common with all of our parabola functions? All the parabola functions have a what going on with it. Jason, what do you think? I know. So the question was, what is in common between all parabolas? What is common within the function of each parabola? The expression that gives the parabola shape. What's in common?
There's a variable.
There are variables. Good, good. Anyone else? Yeah, Justin.
There's an exponent.
There is an exponent, and that exponent is? No, not me. Malik? Squared. Squared power. All of our quadratics we dealt with, right, have had x squared, ax squared plus bx plus c. All these equations we've dealt with before, functions. So our quadratic just has a squared function. It's a squared exponent in the function here. So we'll go ahead and map this out. This is a quadratic. All right. So this is, I'm going to put, these are our parabolas. It has a unit squared, some variable. So it has to have a squared exponent out there. So a quadratic expression could just be one term. If our b and c are equal to 0, we just end up with that first term. So you can have a quadratic that is a monomial. All right. So this is just to get the vocab out there. We're going to do the cookie catcher now. Outro, Let's see. You got an outro idea? No? Not a handout. I don't know. Our outro intro. Oh, I just knock it off? All right, let's see. Wait. All right, my suggestion was